Hi everybody, so today we're going to be talking about Addison's disease. So let's jump right into this. And first of all, what is Addison's disease? Well, Addison's disease is a condition in which the adrenal glands do not produce enough cortisol and they do not produce enough of aldosterone. And we'll go into these in just a minute, okay? So now, here's what happens in Addison's disease. Is normally these are secreted by the adrenal gland, which I have an adrenal gland drawn right there. You have two adrenal glands, there's one on top of each kidney. So what happens is you get damage to the adrenal glands, and like I said, I'll go into that in just a minute. But you can have 90% of the adrenal gland damaged and it will still function properly, okay? So basically you have to have for the most part, you have to have over 90% of the adrenal gland damaged before you're going to impair the function, okay? So now, what causes the damage here? So the causes. If you're in a developed country, so if you are in a developed country, normally this is going to be due to some type of autoimmune disorder. So what I mean by that is it's going to be your own white blood cells attacking the adrenal gland. In underdeveloped countries, what's going to happen, or we could also just call these developing countries, but usually what's going to happen is Addison's disease is going to be caused by tuberculosis. So tuberculosis is a condition that starts in the lungs, and then in this case, it's going to work its way down to the adrenal gland. It gets into the bloodstream, then works its way down to the adrenal gland and causes problems. Another thing that can actually cause problems, or that can cause Addison's disease, is metastatic carcinoma. So metastatic carcinoma is a cancer that starts somewhere else in the body. A lot of times it'll be the lungs, and then it works its way down to the adrenal gland. So let's take a look at what's going to happen here, okay? So for the most part, what I've drawn here is I have, and I know there's a glare right in the middle of that, but I'll try to avoid that. I have my adrenal gland here. So like I said, you have two adrenal glands, there's one on top of each kidney. In the center of the adrenal gland, you have something called the adrenal medulla. And then on the outer portion, you're going to have what we call the adrenal cortex. So this is the adrenal cortex. That's going to be this outer area that's here. Okay, so that's my adrenal cortex. Now, in the adrenal cortex, you basically have three different layers that are in here. Okay, so I'm not going to draw this going all the way around, but imagine I have three layers going around this adrenal cortex. So here's what's going to happen. I'm going to take these three layers right here, and I'm going to do a cutaway, and then imagine I take this and I put it right here. So when we look at these three layers, or what we like to call zones, you're going to have something called the zona glomerulosa, and this is going to secrete aldosterone. Then what's going to happen, then the other area, or the next area you're going to have, is what we call the zona vesiculata. And this is going to secrete cortisol. Okay, cortisol is normally secreted in times when you're under stress. And then down here, you're going to have what we call the zona reticularis. Okay, so let's make this look like an E. Okay, so the zona reticularis. And this is going to basically secrete androgens, and those androgens are going to go on and make a small amount of testosterone. Okay, so let's take a look at what's going to happen here. We're going to take these individually. So let's start with this zona glomerulosa, okay? What we're looking at right here is what we call a nephron. A nephron is the functional part of the kidney. So basically what's going to happen is you're going to have your Bowman's capsule right here. And then when blood pressure drops, what the kidney's going to do is it's going to secrete a hormone called renin. Now at the same time this is secreted, the liver is going to secrete something called angiotensin. And what renin's going to do is it's going to turn angiotensin into angiotensin 1. Then you're going to have something called ACE, which is another enzyme, and it's going to change this angiotensin 1 into angiotensin 2. And then this is going to come up and it's going to bind onto a receptor in the glomerulosa, or the zona glomerulosa, and secrete aldosterone. Okay, so let's take a look now of what this is going to do. So over here, I actually want to kind of separate these out just a little bit. We're looking at two different cells here. Okay, this is going to be called the principal cell, and this is going to be called the alpha intercalated cell. So if we look at this principal cell here, if you look at the principal cell here, this is what's going to happen. I'm going to have aldosterone. Aldosterone is going to be secreted. It's going to enter into the bloodstream. So let's say this is my aldosterone now. Okay, the aldosterone is going to leave the bloodstream, and it's going to come to one of these pumps here, and we're going to call this the sodium potassium pump. So what the sodium potassium pump is going to do is it's going to take calcium, I'm sorry, not calcium, it's going to take potassium that's in the bloodstream. All right, so here's my potassium in the bloodstream, right? And it's going to take that and it's going to pump that into this principal cell. So now I'm going to start to get a buildup of my potassium, right? I'm going to get a buildup of potassium. As the potassium builds up, the concentration increases, and eventually potassium leaves the principal cell, and it's going to go into the urine, and then it's going to be urinated out. So here's my potassium inside of the urine. The other thing it's going to do is it's going to take sodium that's in here, and it's going to take the sodium and it's going to pump sodium up into the bloodstream. So now I'm going to start to get a buildup of sodium in here, in the bloodstream. Well, normally what happens is where sodium goes, water follows. So what's going to happen now is, first of all, a few things. First of all, because this sodium's going out, the amount of sodium that's in this cell is going to decrease. When that decreases, what's going to happen is the sodium that's in here, that's going to be in the urine, is going to come out, and it's going to come into this cell. So it's going to be replacing this because this has gone up into the bloodstream. So what's going to happen next, though, is where sodium goes, water follows, for the most part. So now what's going to happen is we're going to have water coming out from here. It's going to come up through here, and it's going to enter into the bloodstream also. So now that I have more water in my bloodstream, what's going to happen is I am going to have, the heart's going to have to push that extra water. Well, because the heart has to push that extra water, I am going to get an increase in blood pressure. So now my blood pressure goes up. Now remember, this isn't always a bad thing. Sometimes you need to raise your blood pressure to things. We're going to look at that in just a minute. Over here, this is my alpha intercalated cell over here, right? So here's my principal cell, there's my alpha intercalated cell. So what is this going to do? Well, this is going to take hydrogen ions, right? This is going to take hydrogen ions and put them into the urine. At the same time, and oh, by the way, this is called, this right here is called my ATPase pump. So my ATPase pump is going to take this hydrogen and pump it into the urine, right? At the same time it's going to do this, it's going to take, this is called an ion exchanger. And what this is going to do is this is going to take ions such as HCO3, and it's going to take this and pump it into the blood. When this goes into the blood, it's going to increase the pH of the blood. Now remember, if we increase the pH of the blood, we're making it more of a base. So what's going to happen now? When someone has Addison's disease, what's going to happen now is, let's first look at this. We have this sodium potassium pump here. Well, what's going to happen with the sodium potassium pump is now I can't pump this potassium out. So it's going to start to build up in the blood. But more importantly, what's going to happen is now the sodium is not pumped in the blood. Because that sodium is not pumped in the blood, this sodium doesn't leave the bloodstream to replace it. So now you're gonna have more sodium in the in the urine. You have more sodium in the urine, which is going to be urinated out, right? So that's what's gonna happen. That's the first thing that's gonna happen. Because of that, the body's gonna want to have you get more salt. So one of the symptoms of Addison's disease is a craving for salt. Okay? The other thing that's going to happen now is because of the fact that I don't have the sodium going into the bloodstream, what's going to happen is they'll have the water going in there. So now I'm going to get a decrease in blood pressure. So because I get a decrease in blood pressure, some of the things that can happen is something called orthostatic hypotension. And I'm just writing this because it's a big word. Actually, this is the lightheadedness that people feel when they stand up after they've been laying or sitting a while and they get that lightheadedness. That's going to happen from this. So lightheaded upon standing. All right? Some other things that's going to happen is nausea. Sometimes people feel nauseated, vomiting, and things such as that. Okay, so there's two things that are going to happen. So I'm going to be urinating out more sodium, and because the sodium is not going into the bloodstream, my blood pressure is going to go down because I'm going to have less water in the bloodstream. On the opposite side, these ions here that are being taken from the blood and pumped into the urine, what's going to happen is they're going to start to build up here in the bloodstream, right? So because those build up in the bloodstream, remember when you have hydrogen ions, that increases the acidity. So instead of my blood becoming more of a base, now my pH goes down and it becomes more acidic. And this is what we call acidosis. So that's just if we have the problem here with aldosterone, right? So that's the problem that if we have aldosterone. Let's take a look now on what's going to happen if we look at the zona fasciculata. Remember, we said cortisol is usually released when we have, cortisol is usually released under times of stress. I'm sorry. Let me come back over here and let's take a look at how this works. So this is on the brain on someone facing that direction, okay? Let me move this. On someone who's facing that direction. So here's what's going to happen. This right here is the hypothalamus. Okay, now, the way this usually works is like this. The way this usually works is like this. When you get a decrease in cortisol, what's going to happen is it's going to signal the hypothalamus, or the hypothalamus is going to sense that there's a decrease in cortisol. What the hypothalamus is going to do now is it's going to release something called corticotropin releasing hormone, okay, or what we like to call CRH. Okay, so there's my corticotropin releasing hormone. So now what's going to happen is this corticotropin releasing hormone is going to go from the hypothalamus and it's going to come down here into what we call the anterior pituitary. So this right here is my anterior pituitary gland. Okay? And from there, what's going to happen is this is now going to go into the bloodstream. I'm sorry, what's going to happen first, oops, I made a mistake. What's going to happen first is this is going to cause something called adrenocorticotropic hormone to be made. So now, this is going to cause adrenocorticotropic hormone to be made. Now, adrenocorticotropic hormone is also known as ACTH. ACTH now is going to enter into the bloodstream. It's going to enter into the bloodstream and it's going to go up here to my zona fasciculata, right? So here comes my ACTH and it's going to go to the zona fasciculata, but it also goes to the zona reticularis. Okay, so let's take a look of what's going to happen here. So I'm going to go all the way over here. See if I can move that layer right there. And this is going to be the liver now. So this is the liver. So here comes my cortisol. Right, here's my cortisol. And what's going to happen is the cortisol is going to cause the liver to do something that we call gluconeogenesis. Now, if you recall, gluconeogenesis is when we make glucose from non-carbohydrate sources. So what cortisol is going to do is it's going to activate gluconeogenesis, making glucose from non-carbohydrate sources. So it's going to make glucose. Now, remember, this is in times of stress. So what's going to happen is we want to increase the amount of glucose that's in the blood. So what's also going to happen now is when we get an increase in glucose, we get an increase in energy. Okay, we get an increase in energy. So now, here's the next thing that's going to happen. Cortisol is also going to go, and it's going to go out to lipids. And what it's going to do, am I in that glare right there? Yeah, I think I am. Let me move this real quick. And so what it's going to do is it is going to cause the lipids to be broken down into fatty acids. Okay, so it's going to break it down to fatty acids. Now what's going to happen is those fatty acids are going to come into the liver, and they're going to be part of gluconeogenesis, right? The other thing it's going to do is it is going to go out to muscle. Right? It's going to go out to the muscle, and it's going to cause the proteins in the muscles to be broken down, and the proteins are going to be broken down into what we call amino acids. So what happens now? The amino acids now go to the liver, and they become part of gluconeogenesis, okay? So that's the second thing that this is doing, right? Or actually, I should say the third, because it's doing gluconeogenesis. Responsible for that. It's responsible for breaking down lipids into fatty acids. It's responsible for breaking proteins down into amino acids. Those go here, we end up with glucose, we end up with more energy, right? Here's the thing though, it's under times of stress, what's gonna happen is we are going to get, we don't get cortisol released, right? I'm sorry, when there's damage in Addison's disease, we don't get cortisol released. So if we don't get cortisol being released, we don't get the gluconeogenesis, we don't break down the fatty acids, we don't break down the amino acids, we get a decrease in glucose, and we get a decrease in energy from there. So that's another thing that'll happen. So another symptom of this is people become lethargic, or there's a decrease in energy, right? So anyways, that's what's going to happen there. You become lethargic, or there's a decrease in energy. But here's another thing that can happen. Let's go all the way back over here to my brain, right? And as we're making this ACTH, there's an intermediate hormone that's being made. And what's going to happen is that's going to activate something called melanocyte stimulating hormone. Okay, so melanocyte stimulating hormone is going to do exactly what it says. It's going to stimulate melanocytes. If remember, melanocytes are responsible for skin pigmentation. So what's going to happen now is you're going to get hyperpigmentation. And hyperpigmentation means your skin becomes darker, right? So the skin becomes darker, especially around joints or exposed areas, the skin becomes darker. So if you recall, John Kennedy was known for his tan. And really what he had is he had Addison's disease. And therefore, when they thought he was tan, they actually, because of the Addison disease, he had hyperpigmentation, and so his skin had become darker. The last thing is, if we look right here at the zona reticularis right here, what's going to happen is we have these androgens, okay? So we have two different effects. The first one is going to be in males. Now, basically, males, this doesn't play a big role. This secretes very little testosterone here. It secretes very little testosterone. So this in males, it's gonna have to do with some secondary characteristics and development and things like that in males. But for the most part, for men, we get most of our testosterone from our testes, right? So therefore, Addison's is not going to have a big role in when this zone's affected. However, in females, what can happen is this can be responsible for growth. Remember, it's just a little bit of testosterone, just a little bit. So it's going to have a little bit of an effect on females. So it's responsible for growth. It's responsible for pubic hair growing, pubic and underarm hair. And it's also responsible for an increase in sex drive. So now, if you look, if we're not producing this, if we're not getting that little bit of testosterone, in women, these things don't happen. They lose pubic hair, they lose the hair under their arms, they get a decrease in sex drive, and then depending on when it occurs, normally people are already grown by the time this occurs, it's not going to have a big effect on growth, but it could. All right, so that's it for Addison's disease. Thank you so much for watching. If you enjoyed the video, please hit the like and subscribe button, and we will catch you next time.